Hello, in this video I'm going to solve two problems. As you can see, problem number one, we were given two MIPS machine codes expressed in hexadecimal. As you can see, problem A and problem B, they're hexadecimal. Our goal here in this problem is to find the MIPS assembly instructions. In order to do that, we must convert both of them into binary format. All right, next slide. Here we have three tables. These three tables are going to help us to understand how we're going to solve problem number one. As you can see, opcode, RS, RT, immediate data are the data instructions we're going to need in order to have or to find our answer. From bit 31 through 26 is going to give us opcode, 25 to 21, RS, 20 through 16, RT, from 15 to 0 is going to give us immediate data. Okay, our second table right here that we have in here is going to give us or provide us how we can convert the hexadecimal from our part A into a binary format. As you can see, digit number 1, which is digit 3, we convert that into a binary number, which is 00001. When we plug in those 00001 in our table, we can find our correct answer or opcode for this problem. You can see the opcodes or values are right here. Third table right here is going to help us to find the registers. But in order to find the registers, we need the numbers, which are going to find from this data, from the second data. As you can see, the part A, we already converted the part A into a binary format. Once I convert into the binary format, I can find the opcode, the RS, the instruction, the immediate data as well. Okay, for the first 6 digits, like you already know, 31 through 26, is going to provide us the opcode, which is Andy. As you can see here, we found the Andy, which is the opcode for part A. In order to find the RS and RT registers, we're going to need two values, which are 4 and 10. Those two values are going to need it in order to find the register in the next slide. Okay, the next slide, as you already know, we have for the RS 4 and the R10 is 10. Once we look at the table with those two values, we can see for the RS we have the $sign AO, and for the value 10 we have the $sign T2. For the immediate value, as you can see from our conversion in our data, we can determine the immediate values as 0006. Our final answer for part A is this one right here. Okay, for part B, we're going to use the same data table discussed in part A, and also we can't forget that we must convert the hexadecimal into a binary format. As you can see, we have the two data tables, and as well the part B already converted into binary format. Once we got that into a binary format, we can determine the opcode for problem B, which is BEQ, and also the register number, which is 0 in $sign D2, and the final answer is BEQ $sign T2 0 and the immediate data. For problem number 2, as you can see, we were provided data. This data is going to provide us all the information that we need in order to find our final answer. However, we must not forget that for instruction 4 through 7, instruction for 4 through 7 are executed 5,000 times in a loop. So the values from CPI cycles energy must be multiplied by 500. As you can see, we have one set, 2 reds, 2 odds, 1 branch, and 1 right. We're gonna need this set of instruction in order to move forward and to solve this problem. and solve the First, we're gonna need to calculate the total CPI cycle. Second, to find the total amount of energy. Third, compute the MIPS milliwatt metric. First, as you can see, we're gonna find this. Gonna use the data table provided on the problem. You can see we're gonna use CPI 6. I'm gonna use because this is the red, so 2 of them, so it's 18, and we got 2 because we got odd, as you can see it's 2, and the 24, as you can see it's 24 for one branch, and we multiply those together and add them by 18, and we get a total CPI, which is 140060. Moving on the second step, we must calculate the total amount of energy. In order to do that, we must do the same step we did on the first step. However, this one is the energy, so we use this column right here without forgetting the instruction for 4 through 7 that must be executed 500 times. Once we plug in the numbers for the first one, which is the set, so it's right here, 2 reds, as you can see it's right here, 12 and 12, and 18, multiply by 5,000. Added times 2. So we get the total energy in joules. We must have this answer in joules. Okay, third step, to compute the MIPS milliwatt metric, we need first to compute the power in watts, which we must use this formula in order to find the power in watts. Okay, we cannot forget we were given this in the problem, the 333 pegs in the problem. So we plug in the values we got from problem from step 1 and 2 into our formula. Once we do that, we're gonna get a total of 4.5 watts. Third step, we're gonna have the total. We're gonna need to find the total number of instructions. It's only one instruction at all times, so we plug it into our formula, and we get a total of 15,504. The final step, we must find the MIPS. We're gonna use this formula right here, the total number of instructions divided by execution time, which we got from the previous steps. We divided those without forgetting the 300 pegs, and we get a total MIPS 321.1 milliinstructions a second. We must not forget we had to multiply that value divided by the power, which we get the final answer at 0.071. Thanks for watching.